At the end of the day, it's always a philosophical question, right? Of why are we in this universe? And understanding how this universe works is kind of those first steps. My name is Luis Dominguez, and my job is to assemble all the different components for the Psyche spacecraft that is going to go investigate a metal-rich asteroid. We're going to go investigate the largest metallic asteroid that's out there. The more we understand that, we think that can give us a lot more insights on what our actual planet is doing. And welcome to High Bay 2 at JPL. This is the Psyche spacecraft. And so this is where we control the Psyche spacecraft. They dictate how things happen on the floor in the high bay and make sure that the spacecraft is safe. My team's job is to assemble the flight vehicle. We pull together all the different components that everyone's building, bring it together, make sure it works. We bombard the spacecraft with as many tests as we can to make sure that the flight software is as rugged and the hardware is as rugged as it needs to be to get those requirements accomplished, and then throw it on top of a rocket and launch it. It's amazing. I mean, growing up where I grew up, I never thought I would be working on anything like this. Never thought I'd be capable of doing something like this. So that's one of the biggest things that kind of drives me. I like to do a lot of outreach and go out and talk to kids, especially from like socioeconomically disenfranchised areas, because I get them. And I always tell them, live your life with courage, curiosity, tenacity, and a healthy dose of altruism. Seeing their eyes shine up, it's just truly awesome.
Hi everyone, I'm Raquel Villanueva here at NASA's Jet Propulsion Laboratory in Southern California. In just a moment, I'll be joined by Luis Dominguez to answer your questions about Psyche, a first-of-its-kind mission that, after it launches next month, will travel beyond Mars to explore an asteroid made not just of rock and ice, but a significant amount of metal. The video we just watched introduced us to Luis Dominguez, who is now in Florida getting ready for launch. And he's joining us live to answer your questions. Thank you so much for joining us today, Luis.
Thank you so much for having me, Raquel. Should be fun.
Yeah, this will be super fun. And if there's an engineering question you'd like to ask Luis, post it in the comments on the stream you're watching or send it using the hashtag #AskNASA. Now, Luis, for those just joining in, can you give us a quick overview of Psyche and your role on the mission?
Yeah, absolutely. So Psyche is a mission to go investigate a metal-rich asteroid that sits in the asteroid belt between Mars and Jupiter. It's about 2.6 astronomical units from the Earth, which roughly translates to about 250 million miles. Which is a good distance away. And I am the manager for the Assembly, Test, and Launch Operations team, which is a large team composed of several sub-teams that involve a mechanical sub-team, an electrical sub-team, and a systems sub-team, along with quality assurance and other folks who help us put the spacecraft together and test it and then launch it.
Great. And, with Psyche just a few weeks away from launch, what preparations are being made now? And what are you working on specifically at this moment?
Right now, we're specifically working with the SpaceX team to get it integrated onto what's called the payload adapter assembly, which is what's used to affix the spacecraft onto the rocket. Once we get it onto that assembly, we'll clamshell it together and encapsulate it in the fairings, and then work with SpaceX to get it installed onto the rocket after they do a quick static fire test, which is always a lot of fun.
It sounds like it. And you mentioned it in the video, the importance of testing the spacecraft. What specific tests were done for this mission?
So the ATLO campaign is always, and that's Assembly, Test, and Launch Operations, comprised of what I like to say: we build it, shake it, bake it, and then we launch it. So we'll build the spacecraft, take all the different subcomponents from all the various vendors and partners that we have, start testing the spacecraft with various tests that we come up with, and then put it through an environmental test campaign where we will shake it and put it through its dynamic test campaign where we simulate being on the rocket, because that's the most dynamic environment that the spacecraft will kind of have to endure. And then we'll put it into a thermal vacuum chamber where we'll test being in space effectively and simulate being very cold, very hot, and fully pull out all the air and molecules to make sure that that nothing starts outgassing you. You kind of don't think about it, but when you're in a vacuum, things kind of just start falling apart. Um,
It's so interesting to hear about all the types of tests that are needed to simulate space as well. And,
yeah, no, it's
we learned, oh, go ahead.
no, yeah, it's we'll simulate kind of being super hot, super cold, and then after we're done with that, we'll work on getting it ready for launch, kind of doing final preparations and everything, which is basically where we're at today.
And, we also learned in the video that you like to do a lot of outreach. So, what type of questions do you get most from some of the kids you speak to?
Yeah, I was speaking to kids. They always have the most kind of off the wall questions that they throw at you, like how far is the moon away from Earth? What are black holes made out of? And I always like to kind of throw it around back at them, right? Because we have folks with PhDs who have no idea really how what black holes are made out of, and the intricacies of that. And so, I challenge them to go out there and figure out what black holes are made of. Start studying that, and you could be telling us what black holes are made out of.
That's great that you're putting them to the test too. And I feel like kids also really give questions that I think adults sometimes I know I'm afraid to ask. So I love that aspect about it too.
Yeah, absolutely. They're definitely generally much more courageous, I would say, and are more curious and don't have that kind of fear of being laughed at or that adults kind of get.
Yeah, it's a fun time. And I have a couple more questions for you before we get to our social media questions. I know you're in a very cool looking room right now. Can you kind of explain where you are and where you'll be for launch?
Yeah, so this is our control room, which we call the system test complex, where we um, basically control the spacecraft all the way throughout the launch campaign. We'll do various small tests going forward from here to verify that there's nothing wrong with the spacecraft as we're integrating it with the rocket. And I will be here during the launch with my team as the spacecraft anomaly lead, kind of trying to respond to any potential issues that might crop up.
Wow. And then I have to know, what are you most excited about when it comes to Psyche?
I'm most excited about the science, of course. It's going to be very interesting to go and investigate an asteroid, which we believe is the failed core of a planetesimal, right? Something that, um, you know, started forming in the early parts of the solar system, in the early periods of the solar system, and due to tidal forces from Jupiter and Saturn, right, had another object collide with it and potentially create this core that we can use to better understand our own core on this planet and a little bit more about the universe.
Well, thank you, Luis. Fantastic answers. Now, I have some questions coming in from social media. And as a reminder, if you have an engineering related question for Luis, you can ask it using the hashtag AskNASA or by writing in the comment box wherever you are watching this broadcast today. So we have a viewer on Instagram who wants to know, what major challenges did you encounter and how did you tackle them when it came to Psyche? You touched on it a little bit before, but for those tuning in, what would you say?
Yeah, well, probably one of the most challenging aspects was building a test chamber within our vacuum chamber. We had to basically build an oven within it to be able to simulate all the different heating all the different sides of the spacecraft in different aspects, and simulating the hot and cold environments in space. And that was a truly challenging feat, but our mechanical lead, Dave Verdal, did an amazing job pulling that together. And of course, a lot of other folks helping him out.
Absolutely. And another viewer on Instagram wants to know, what basic materials were used to build the spacecraft?
Well, the spacecraft's got a lot of carbon fiber composites, a lot of honeycomb materials made out of aluminum, and we use many different types of alloys of metals. And yeah, it's mostly metals, and you've got a ton of circuits, so a lot of silicon, right, to build these boards, and pull it all together. Copper, lots of wires in the spacecraft.
Wow, that's kind of the first time I've ever heard anyone ask that question. Really interesting answer. And now we have Mark Kenton on Facebook who asks, who figures out the hardware assembly sequence?
That is actually part of the ATLO kind of early planning. And usually in the proposal phase, which is kind of the early phases of developing a project, you come up with a more or less outline of how you're going to build everything, when things are going to come in. And then the metal, right, the rubber hits the road when you get into ATLO, which starts towards the middle of the campaign. And usually you got to throw that plan a little out the window because things show up at different times. Things that you thought were going to show up earlier actually show up more towards the end. And so you have to rejigger everything and reschedule everything to make sure that you're properly testing everything as it's coming in, and you're not going to be surprised once you get to the end. So it's a challenging feat, but the ATLO team kind of works together to kind of get that all done and make sure we meet all our requirements and everything works properly.
Great. And, for those just tuning in, you are the ATLO manager. Can you kind of explain what that stands for and what you do?
Yeah. So assembly, test, and launch operations is the team that assembles the spacecraft, tests it out in all aspects. So, we do functional tests on all the different instruments. For example, our gamma ray neutron spectrometer, we actually put a small kind of thermal vacuum chamber around it. And then we'll actually bring a radioactive source near it to test out its detection of gamma rays and neutrons. And it's funny, you could actually use 10 bananas to do that because potassium has enough, 10 bananas provide enough potassium to excite the instrument. But we actually use horse salt to test it out. And then our magnetometers will install these cans that simulate different magnetic fields and remove the Earth's magnetic field.
I never thought of now Psyche and bananas, but now they're paired in my mind after that. We have another question coming in from Dynamic Space Babe on Instagram who asks, how long does it take to prepare to go inside the clean room? That room we saw at the beginning in your video, like suiting up in what we call the bunny suits and all of that.
Yeah, so suiting up is actually, once you get really good at it, you can get it done in about 5 minutes for Psyche. We're only using gloves and a frock, which is embedded with kind of metallic material to remove any static electricity that you build up on your body. And you also use a wrist strap to ground yourself to the spacecraft, and some booties. So the cleanliness requirements weren't nearly as tight for Psyche as some other projects. I previously worked on Mars 2020, and in that project we had to use full bunny suits where we kind of totally covered our heads. You could only see our eyes, right? And and we had full boots and double glove, everything. So yeah, that one was a little more challenging. But once you got it down, that was probably about 7-10 minutes.
That's still really impressive. Like I was saying, it feels like you take like 5 minutes to put on a glove, at least for me. So the fact that you can just get in there and go is really impressive.
Yeah,
we
practice
have
makes
some
perfect.
more questions. Exactly. We have some more questions coming in. How did you reduce the damage of systems on board during launch from vibrations? All right. I can read that again if you need me to.
No, I get where they're going with that. Yeah, overall, we don't want anything damaged during launch due to vibrations. And that's specifically why we put it through this dynamic test campaign where we slowly, we put the spacecraft on a shaker table and we simulate all the different axes and we slowly increase the vibration level until we get to a little bit over the vibration level that we expect to see for launch. And then while we're doing that, we're still testing the spacecraft constantly to make sure it's still working. And that's how we ensure that it'll survive a rocket launch, it's pretty wild.
Oh, and then we have another question coming in from Prasad Sakul on YouTube who asks, how are the aspects of spacecraft performance in microgravity or zero gravity tested?
That is actually quite difficult to test on Earth, and we don't normally test that per se on Earth. A lot of the instruments have high heritage and have been kind of developed with high heritage components, subcomponents in mind. So we know how they'll work in microgravity. But one of the things that we actually do test out is our solar array deployment. Our solar arrays, we build this giant fixture to offload the weight on the solar arrays as they're being deployed, so we can actually test out that they properly deploy here on Earth. But of course, they're designed to work in space and with no gravity. So if we were to not provide this offload fixture, they would just fall apart. So it kind of depends on the instrument.
Yeah, and we have a lot of great questions coming in still. If you have a question you'd like to ask Luis, use the hashtag #AskNASA. And we have one now from Joan Fenchner on YouTube who wants to know, I'd love to know how the heat emissions, one second. Actually, we have one from Pershner on YouTube asks, why does humanity need these kinds of missions?
Yeah, no, absolutely. I mean, so these missions force us to kind of think of different off-the-wall ways to do things. And oftentimes in doing these sorts of exploratory missions, we develop technologies and we develop new things that we can use here on Earth. And it just provides us that much more information. In this case, we're going to investigate an asteroid that we think is a failed core of a planet. And that's something that we would never be able to investigate here on Earth. It is almost near impossible to reach the core of the Earth, as even though Hollywood would like to make you think it's something that can be done, but getting down there, the pressures are too extreme, and so being able to investigate something, a heavenly body that's in the middle of our solar system is much more doable, and it will give us much more information about how our Earth is made, and we get more information about how it works.
Fantastic. And I know you answered this question before, but people are tuning in live as we speak. So Betty on Facebook wants to know, what was the most challenging part of Psyche's development?
Yeah, like I said, it was mostly getting that vacuum chamber, that thermal, building an oven within the thermal vacuum chamber, so that we can do all the different testing and simulate all the different potential kind of thermal environments that the spacecraft is going to be in. But it's also difficult figuring out what to test on a spacecraft, right? There are so many, we can think of endless amounts of tests to do, and we could test ad infinitum, but we have to get it down to a subset of tests that will prove that the spacecraft's going to work to do what we need it to do. And what we initially proposed it would do in its proposal phase, right? And that's to go investigate this asteroid and see if it was potentially the core of a failed planet, which we think is primarily composed of nickel and iron.
And I feel like this is kind of a related question. So Bryant Lopez Roman on YouTube asks, what would you want kids to specifically know about Psyche and its mission? And what should kids know that makes this mission so much more different than others?
I mean, overall, I would say kids should want to learn about how the Earth works and overall how this universe has come together. It's a very kind of big question, but in understanding that, it makes you think and expand your mind out and think of different possibilities. I never thought I'd be working here at JPL and building satellites to go investigate asteroids in the middle of the solar system. But here I am, and being able to ponder those questions and be willing and courageous enough to ponder those questions. That's really what, I would say kids should learn from it.
It's a great message. And we also have Don Horstrom on YouTube who asks, how are spacecraft builders using origami for the designs of solar arrays and communication antennas?
Yeah, no, origami is an interesting art form. And it allows us to pack a very complex structures into very small shapes and make them lighter a lot of times as well. So size and mass are a big aspect of what we can send into space. And so the tighter we can pack things in, and ensure that they will deploy, right? Also,
Mhm.
is important for space. So our solar arrays, as you can see, were somewhat inspired by origami, but there's some more complex structures out there that we put on telescopes, like sunshades on the Spitzer Space Telescope, which is an incredible kind of deployment uh, action, as well as the James Webb Space Telescope, which was also folded up very nicely to fit within the Ariane space capsule.
Yeah, it's awesome to watch them deploy. That was a really great question. And we have another one coming in from Menno on Facebook who asks, is there gold on the asteroid?
There is a possibility that there is gold, along with other metals, other various types of metals, not just nickel and iron. And it's, but we don't know the amount of gold that would be on there. It would be much higher than what we normally find on Earth, right? Because the minerals that we find on Earth are kind of embedded within a silica rock layer, and so where we go mining, there's typically a very low yield of metal for the rock ore that we're mining. Whereas here, we believe it's a highly dense, highly metallic asteroid that will have much more dense levels of different types of metals, but primarily nickel and iron.
Right. Thanks, Luis. And then we have a question from Bruce McNitch on YouTube who wants to know, will your involvement with Psyche end at launch? And if so, after a well-earned vacation, so we want to know your vacation plans now, what is the next project you'll be working on?
Yeah, so I typically like to work the kind of the assembly, test, and launch operations aspect of the spacecraft process. But after we launch it, we hand it over to the operations team that kind of gets it the rest of the way there. I mean, after we launch, we've still got about 6 years of travel to get to the asteroid, and we'll be using our solar electric propulsion to get us there. But my next project is the sample return lander mission, which is a mission to go and retrieve samples from that Perseverance has been collecting and get them out into orbit to get them sent back here to Earth so we can study them a little more closely.
Shifting gears all the way over to Mars now.
Yep.
And
we'll
we
actually
also
fly by
have.
Mars on.
Oh, really? Yes, that's right.
Yeah,
So you'll to Mars.
We'll do a gravity assist around Mars as part of our trajectory orbit to get to Psyche.
Great. And then we have another question coming in from a kid. Nokabo Shop Metformosi on YouTube asks, hello, JPL. I'm a 13-year-old kid from Greece, and I have a question about the spacecraft. How do you navigate Psyche?
So we navigate Psyche using solar electric propulsion thrusters. These are Hall effect thrusters that use xenon gas, and what they do is they accelerate the xenon gas up and shoot it out the back of these thrusters. But we also have cold gas thrusters that we use for minor corrections of the spacecraft's attitude. So we'll use that, and also reaction wheels, which are essentially very large masses of metal that we spin up to kind of move us in a particular direction and get us oriented. But it's primarily the solar electric propulsion that will get us to Psyche, and along with the gravity assist from Mars, and our trajectory that we get into as soon as we leave Earth's orbit.
Great. And we just have a few more questions left for you, Luis. Arza on Facebook asks, can a materials engineer work on this in the space industry, like construction of these types of spacecraft?
Yeah, absolutely. There's a lot of work right now going into 3D printed additive manufacturing, and how we use that in space. There's a lot of questions on how to use additive manufacturing because it gives slightly different properties from what we're expecting, through most material processes. But yeah, materials engineers are key to doing a lot of the work. I worked on the Mars 2020 actuators, and we actually tested out making shafts out of different types of metal to reduce magnetic disturbances that we were seeing on some of the sensors. And we used it just to test it out and get an idea of if this is something we could do in the future. Because in doing additive manufacturing and doing these kind of different techniques, you don't know what the end result's going to be. So you got to get more testing done to really use it in space.
All right. I have one last question for you. What was your path like to your current career, and what advice do you have for others?
Yeah. Overall, I've had several careers or several jobs. I started as I've done gardening. I've worked at McDonald's, Carl's Jr., and Taco Bell. Kind of, you name the fast food place, I probably worked there. But I started at JPL as an intern in college, working on the Curiosity team, as their on the Atlo team also as an intern. And I studied mechanical engineering, so I kind of got put into the electrical engineering team, and kind of just moved on from there. I do know mechanical engineering fairly well, but now I primarily focus on testing electronics and testing the software, right, that controls all the spacecraft. So it's been a fun ride, and I've been able to learn a lot from all the different amazing subject matter experts that we have here at JPL.
Well, that was a fantastic half hour with you, Luis. I loved hearing about your journey, and thank you so much for joining us today.
Thank you. Thank you for having me, and it was an honor.
And I'd like to thank everyone at home for submitting your questions. They were fantastic. So to stay updated on the Psyche mission and its October 5th launch, follow NASA JPL and NASA Solar System on Facebook, X, and Instagram. And to learn more about this unique mission to a metal-rich asteroid, visit nasa.gov/Psyche. Thanks for joining us as we continue to dare mighty things.